Finally, an example. These are the steps we're going to be using to design a column. I went over these steps in the previous video. So let's do a sample design problem. And so the problem we're going to do, let me find the problem. Here it is. So in this problem, we're going to do a square tied column steel on two faces for 350 kips and 110 foot kip moment. F prime C is 4, Fy is 60, and I want about 2% steel. You won't be able to get exactly 2% steel because you can't custom fit the column sizes like 17.3 inches. And so as long as it's close to 2%, I'll be happy. So the first thing to do, which maybe is the hardest step, is to guess your first size. Now for the project, we already had guessed them to be 18-inch columns because of practical reasons. The girders were 18 inches wide, so we wanted the columns to be 18 inches wide. So in that case, you could skip this step and just say we're guessing the columns are 18 by 18. But if you're starting from completely nowhere, this is what you would do. So for the trial size, that's funny, trial size sounds like something you would get at Walmart for toothpaste or something. But anyway, for the trial size of the column, you're going to take F prime C over 2 and then calculate the capacity. Okay, so the capacity, if you remember, was 0.85 F prime C times the area of concrete times Fy times the area of steel. And we're shooting for about 2% steel. So let me turn the pen on. There you can see I'm using F prime C over 2 to get the trial size. I explained that earlier. If the column is 2% steel, it's 98% concrete, so 0.98 times the unknown area, h squared. The Fy is right here. And again, we're shooting for 2% steel, so the steel is 0.02 times h squared. This is the phi factor. .65 because it's a tied square column. If it was spiral, it'd be 0.75. And remember, because of minimum eccentricity, you take off 20% off the top. That was the given, was 0.8. And you multiply all that out, and you get 1.49 h squared equals phi pn, which is pu, and that was given as 350. You solve for h, you get 15.3 inches, and I'm gonna guess 16 inches. Yeah, I'm gonna guess 16 inches. I cheated, that's the answer, but I'm guessing 16 inches. Okay. Okay, so we're going to do 16 minus 5, which is 11 inches between the steel, because 2.5 from each side. So it's 11 inches between the centers of the steel on both sides, divided by 16 is 0.7. That's amazing. We can use the 0.7 chart. Okay, so here's a chart I'm going to use. I've made scans of these. They're 0.6, 0.7, 0.8, and 0.9 for the gammas. And I also found more charts that have like, I think 0.65, 0.75, and 0.85 or something like that from a different book. Anyway, I've posted 7 of these diagrams for you to look at. And what I did, so if you look carefully on this graph, I'm going to zoom, and hopefully I can zoom it back down to fit this VidGrid thing. Let's see how this works. Okay, there. So if you look at the y-axis, it's PU over phi F prime C area gross. And if you look at the x-axis, which is the moment, PUE over phi F prime C AGH. Okay, so look at the axes carefully, especially because I've photocopied these graphs from two different books for you, or scanned them, and the axes are a little different. So be careful when you use these graphs. Okay, just look carefully at the axes, what the variables are on there. So let's see if I can zoom this back out, get this to work right. Oh, a little smaller. Oh, perfect. Oh, too small. Oh, come on. Okay, there we go. That'll fit perfect. Okay. And so the y-axis is P, but you know it's PU over phi F prime C AG. That came out to 0.7. And PU times E is MU. Make sure you change it into inch kips. MU over phi F prime C AGH is what the x-axis said. I got 0.17. And I looked on the chart and I got 0.025, close enough, 2.5%. Again, that's amazing. Obviously, I did this a couple times. I'm just showing you the last iteration. That's the answer. But if you wanted to try to get down to exactly 2%, okay, so this is a little too high, you would make it a little bigger. And you could try 18, but I tried it and it didn't work. But maybe an 18 by 18. You can try that at home. But I'm going to stick with a 16 by 16 and 2.5% steel. Okay? So pick the steel. 2.5% times h squared is 6.4 square inches. And so I looked on that table, okay, and I used the table in Dr. Dolan's book. And anyway, so I was looking for an even number of bars that was at least 6.4 square inches. I came out with 6 number 10s, and his book will tell you for a 16-inch beam, how many number 10s can you put in there, whereas my table is, if you have 3 number 10s, what's the minimum width? Okay, so either way, a 16-inch beam, I figured out, will hold 5 number 10s. You're like, oh no, but we have 6 number 10s. Remember, that's 3 on each side. So 3 will fit. Okay, so it fits, no problem. So it's 6 number 10s, okay? And it's a 16 by 16 inch column. The row has gone up, double check that everything's okay. It's okay. I checked it. The next step is select the ties. Remember 10 and below, it's number 3. It's 11, 14, and 18 that are number 4 ties. Okay, 16 times the diameter of a number 10 is 20.3 inches. 48 times the diameter of a number 3, which is 3/8, is 18 inches. And the smallest column dimension was 16. And you take the minimum of these 3, so the answer is number 3 ties every 16 inches. And you're done. And all you do is you end with a sketch. And so here on the sketch you can see I've drawn 16 by 16 inches. I have 1.5 inch cover. I have 3 number 10 bars each face. And the ties are number 3s at 16 inches. Now, if you really wanted to double check, you can calculate the actual distance from the edge to the middle of the bars and see if it really was 2.5. It's actually, I think, really close in this example. But if you use those large number 18 bars, it can be closer to 3, maybe even towards 3.5 inches. And so just double check that. And I actually drew this thing to scale. and you should do something like that. And because we went for 2% steel, that fits. And the last thing I should check is this distance here. Let me draw. This distance here, that needs to be less than 6 inches. And I'm almost certain that distance is less than 6 inches. Because this is in a corner, so that's safe, it won't buckle. That's in a corner, that's in a corner, that's in a corner. This one is not. And the rule is, if you're not in a corner, you have to be within 6 inches of a neighbor. And so let's see, we should check it right now. That's 8. That is probably, if I had to guess, minus 2.5. That's going to be about 5.5. That's center to center. Yeah, that's going to be like 4.5 inches. So that's less than 6 inches. You're okay. If you had a really big column and that was greater than 6 inches, you have to do this. You have to put another set of bars like that. Okay, that's it. That's how you do column design. We'll do one from scratch with all the steps on Monday. And then after we do this, what we'll do is we'll redo that problem using a spreadsheet. And and I'll try not to cheat on Monday. I'll try to pick a size that's not right, and so you can see how to, if you guess wrong, what you need to do for the next step. Anyway, it's been a pleasure having you in class this semester. This has been a weird semester, one we'll never forget. But I've enjoyed having you in class, even if it's been online for half of the semester. You guys did great.